students. Today we are going to discuss the new topic, that is law of conservation of energy. It states that energy can neither be created nor destroyed, but it can be transformed from one form to the another. Means you cannot destroy the energy or you cannot create the energy, but one form can be transferred to the another. So total energy before and after the transformation remains the same. So prove this by the a freely falling object. We will prove this law by taking a case of a freely falling object. Let an object of mass m falls from point A, that this is point C, ground, this is point A. Object is falling from point A, which is at the height h from the ground, and it will cover a distance x at point B and then reaches at point C. So we are going to discuss the sum of energy, kinetic and potential energy at point A, and we will find out the sum of potential energy and kinetic energy at point B and at point C, and we will see that at all these 3 points the sum of energy remains same or constant. That is the proof of this law. At point A, the object is at rest, so kinetic energy is equal to 0. We write Ek for kinetic energy and Ep for potential energy. And potential energy at this height, we know that potential energy is equal to mgh. So total energy at point A is equal to Ep plus Ek, that is equal to mgh plus 0, and energy at point A is equal to mgh. Now this is point A, this is point B, and this is point C. When object moves from A to B, at point B, it covers, suppose, distance x. At position B, let the body covers a distance x from its initial position. So if velocity of the body at B is v, then we can say v square minus u square is equal to 2as, and v square minus 0, because it is coming from A, it is starting from rest, so initial velocity u is equal to 0, and A is taken as g, acceleration due to gravity. Therefore v square minus 0 is equal to 2gx, which implies that v square is equal to 2gx. Now at point B, the kinetic energy of the body at point B is equal to half mv square. Now value of v square we have calculated over here, so we will substitute this value in this, and we will get half m into 2gx, that is equal to 2 will get cancelled, it will come out mgx. And potential energy at this point, we had potential energy that is equal to potential energy of the body at point B. We'll denote like EPB, means potential energy at point B is equal to, what is the formula of potential energy? mgh. Now h is what? Total height, but object is at this point and this is the x, so height of the at point B will be h is complete and x is covered, h minus x. So potential energy of the body at point B is equal to mg. Instead of complete H, we have to write H minus x. So we will calculate total energy of a body at point B. So E is equal to, that is equal to kinetic energy plus potential energy. Kinetic energy we have calculated mgx, and potential energy is mgh minus x, which will come out when we will simplify mgx, and when we will open this bracket it will come mgh minus mgx. So these two will cancel and the result will be mgh. Means total energy at point B is also mgh, and total energy at point A is also mgh. Now calculate at point C. Point C is just above the earth. So height h is equal to 0, means potential, the height by which the body falls is h. Therefore, the velocity height h is 0, means mgh is also 0. Potential energy of the object is also 0. We will calculate, and we have to calculate the velocity at point C. So again we will use the third equation, that is equal to v square minus u square is equal to 2as. Again initial velocity is considered as 0, a is equal to g and s is equal to h. So v square is equal to 2gh. So kinetic energy at point C, the formula is half mv square. Kinetic energy at point C is half mv square. V is equal to 2gh, half m into 2gh, that is mgh. So total energy of the body at point C is equal to kinetic energy plus potential energy, that is equal to mgh plus 0. So result is mgh. So at all the 3 points A, B, C, the total energy, that is sum of kinetic and potential energy, or we call it as mechanical energy of a body that is freely falling at each point is constant, that is mgh. This is the law of conservation of energy. With derivation you have to write the statement, and it is very important.